In this video, I want to look at what are called the cyclic subsets of a group. To get started, I want to let G under star be a group. And we're going to let little g be any element of capital G. The cyclic subset generated by G is it's first of all written G inside these angle brackets, and it is defined to be the set of all powers. So it's G to the K, where K is any integer. Now this is the multiplicative version of what a cyclic subset is. So that's the phrase that we are defining here. I do want to look at what this looks like in in additive groups as well. So it's important to note that if my group is written additively, then the cyclic subset generated by G is going to be the set of multiples of G, where K happens to be pulled from the integers. And the reason why is that in an additive group, we are looking at repeated addition, and we write this particular thing, K copies of G, as K times G. So these two demonstrations are exactly the same idea. It's just that this top one is if the group operation is multiplicative, and let me make my handwriting clearer. And this bottom one is if the group operation is written additively. So it's important to understand that we do have two different, symbolically different definitions, but they actually mean the exact same thing. So I do want to kind of look at a couple of ideas. So let's see. If I look at the multiplicative group, the non-zero integers under its multiplication, then I can do something like look at the cyclic subset generated by 2, and that would be 2 to any integer power. And so this set would include 2 to the 0, 2 to the 1, 2 to the negative 1, 2 squared, 2 to the minus 2, 2 cubed, 2 to the minus 3, and so on. So in the non-zero rational numbers under multiplication, this cyclic subset generated by 2 would be the set 1, 2, 1/2, 4, 1/4, 8, 1/8. The next one would be 16 and 1/16, and so on. So that gives you one idea of how a cyclic subset might look. On the other hand, if I look at the integers under addition, then the cyclic subset generated by 2 would be all of the multiples of 2. So this would be the set that would look like 0 times 2, 1 times 2, negative 1 times 2, 2 times 2, minus 2 times 2, and so on. So in this particular group, the integers under its addition, the cyclic subset generated by 2 would look like the set containing 0, 2, minus 2, 4, minus 4, 6, minus 6, 8, minus 8, 10, minus 10, and so on. So it's important to understand that the actual set that we get for the notation 2 inside these angle brackets depends upon what group we are looking at. And that's something that is worth writing down. So um, if a particular symbol belongs to more than one group, then the cyclic subset generated by that particular symbol depends on the group under consideration. So the group we are working with. So as we've just seen, if we are letting 2 be inside the non-zero rational numbers under multiplication, then I'm going to call this S1 equal to this particular group is 2 to the k, where k is an integer. But if I'm considering 2 a member of the integers under addition, and I let S2 be the cyclic subgroup generated by 2, this would be 2 times k, where k is an integer. And as we've seen, it is worth noting that S1 and S2 are not the same set.